Hello, my dear friends. Welcome to Canonical Vantage. In this video, we're going to talk about piecewise functions. But before that, please hit that subscribe button so that you won't miss any of my future videos. Now, in this video, we're going to take a little shift because we are actually going outside and see how we can identify piecewise functions by just observing the natural phenomena that is happening around us. So come with me and let's go. This pot contains 9 different kinds of plants. Each plant has a different growth rate, and most living matter grows with successive exponential, linear, and saturation phases, with time as our independent variable. We can model the growth rate as a piecewise function, one for the exponential phase and another for the linear and saturation phase. Behind me is the Davao River. The amount of water that flows in this river, measured in cubic meters per minute, depends on the amount of rainfall measured in millimeters. Philippines has dry and rainy seasons. These seasons affects the flow rates of water in rivers. During dry season, where there is less amount of rainfall, there is less volume of water flowing in rivers. However, during rainy seasons, a significant increase in rainfall results to a huge volume of water flowing through this river every minute. We can define a piecewise function for this phenomenon. One part describing the flow rate during dry seasons, another part describing the flow rate during rainy seasons. Now that you've learned the basic idea of identifying piecewise functions by just observing physical phenomena that is happening around us, let's now get into our virtual blackboard and see some examples of a physical situation being converted into a mathematical functions or mathematical equations. This process of converting a physical phenomenon or physical situation into mathematical function is what we call mathematical modeling. So let's get into it. So in this first example, we're going to look at a jeepney fare. A jeepney ride costs 8 pesos for the first 4 kilometers, and each additional kilometer adds 1 peso and 50 centavos to the fare. Use a piecewise function to represent the jeepney fare in terms of distance in kilometers. Now, in representing this situation as a piecewise function, the first thing that you need to do is to name your function. Here in this case, I'd like to name my function as f of x, but you can choose whatever name you like for your function. In this case, f represents the name of the function, and the x represents the distance traveled in kilometers. So the next step is to observe what are the conditions given in the problem. Here we can see that 8 pesos for the first 4 kilometers as our first condition. Second condition is each additional kilometer adds 1 peso and 50 centavos to the fare. So we can write that here in the first line of our piecewise function, and the second condition, we can write that as the second line in our piecewise function. So in the first line, we can say that you only have to pay 8 pesos when you traveled between 0 and 4 kilometers. Now, how do you represent between 0 and 4 kilometers in mathematics? That is 0 less than or equal to x less than or equal to 4. This means when your distance traveled is between 0 and 4, you only need to pay a constant fare of 8 pesos. Whether you traveled just for 1 kilometer, whether you traveled for 2 kilometers or 3 kilometers or 4 kilometers, you just need to pay the driver or the jeepney 8 pesos. But what if you traveled more than 4 kilometers? And that's what you're going to write here on the second line. So that is, you need to pay 8 pesos plus 1 peso and 50 centavos multiplied by an excess of the 4 kilometers. So that is x minus 4. Because you only need to multiply 1 peso and 50 centavos for in excess of 4 kilometers. So this condition is right whenever your x is greater than 4. So now our second line looks like it's complex, so let's simplify this line. So here we have 8 plus 1 peso and 50 cents for every excess of 4 kilometers. Using distributive property, we can have 8 plus 1 peso. You can just write 1.5x minus 1.5 times 4. So we can have 1.5x plus 8 minus 1.5 times 4 is 6. So finally, we have 1.5x plus 2. Finally, we can rewrite our piecewise function this way. Our f of x equals 8 when your x is between 0 and 4. And then you have 1.5x plus 2 when your x is more than 4. Okay, so here is our final answer. Now, in the second example, we're going to look at overtime pay. You have a summer job that pays time and a half for overtime. A regular job is 40 hours a week for the rate of 49 pesos and 50 cents per hour. Use a piecewise function to represent the weekly pay in terms of hours you work. Now, before constructing our piecewise function, it might be very helpful to first construct a table that will display all the possible conditions given in the problem. In the first column, this represents our input. The second column represents our output. In this particular problem, our input is the number of hours you worked, or hours of work, and the output for this particular problem is your weekly pay or your weekly salary. If you noticed, in this problem, there will be two conditions need to be met. And these conditions will be written in each of these rows in our table. So in the first condition, we have a work from 0 to 40 hours. In that case, you will be paid 49 pesos and 50 cents for every hours of work without overtime. Now, if you work overtime, that is, you are working more than 40 hours, you will be paid the regular rate of 49.5 for the first 40 hours and an additional of 1.5 times your regular rate. So that is calculated as 49.5 times 1.5 times, now here comes the tricky part, because you don't have to write just H, because that represents the total of hours you work. The regular number of hours of work for 40 hours plus the overtime. But in this second part, the second term of our condition needs only to be calculated for the number of hours in excess of 40. So you have to write H minus 40. Now that we've constructed our table, we now move on to constructing our piecewise function. So in this case, I will write g of h, where g is the name of our function and h is the name of our variable that represents the number of hours worked. So let's continue. In the first line will be our first condition. So that is 49.5 times h if you work between 0 to 40 hours. So 0 less than or equal to h less than or equal to 40. But if you work overtime, the second condition satisfies. So this is, so that is 49.5 times 40 for the regular hours of work is equivalent to 1,980 plus 49.5 times 1.5, that is 74.25 times h minus 40 whenever you work overtime, for that is more than 40 hours, h is greater than, let me write that properly, h is greater than 40. Now we're almost done, except that we need to express this second line as simple as possible. You have 74.25 times h minus 40. By using distributive property, we will have 74.25 h minus 2970. So the second line will become 74.25 h minus 2970 plus 1980. So this is simplified as 74.25 h minus 990. So the final form for our function will look like this: 49.5 times h. We can just remove the parentheses and write directly h. Whenever we work a regular hour between 0 to 40, and then the second condition is 74.25 h minus 990 whenever we work overtime, that is h is greater than 40. So this is our final answer. Now, in this third and final example, we're going to look at compensation tax rates. The Philippines taxes its resident citizens on their personal income. For residents with annual income not exceeding 250,000 pesos, no tax is collected. Starting January 1, 2023, for residents with annual income more than 250,000 but not exceeding 400,000, a 15% tax will be collected. And finally, for residents with annual income more than 400,000 but not exceeding 800,000, a 20% tax will be collected. Use a piecewise function to represent the tax collected in terms of pesos. Now again, before constructing our piecewise function, it will be very helpful to construct a table displaying all the possible conditions given in the problem. Again, in the first column represents the input, and the second column will be your output. In this particular problem, the input will be annual income, and the output will be tax collected. So if you noticed, there are three conditions given in the problem. So we will write 3 rows, one for each condition. The first condition is that when you have an annual income from 0 to 250,000, no tax will be collected. So that is 0. If the annual income is more than 250,000 but less than 400,000, or not exceeding 400,000, so that is, let's say our variable, the annual income, will be represented with A. So we have 250,000 less than or equal to A. No, it should be more than A, but less than or equal to 400,000. A 15% tax will be collected. 15% times A, whatever that A may be. And the third condition will be if the annual income is more than 400,000 but is less than or not exceeding 800,000, a 20% tax will be collected. Okay? So this means 0% times A is just equal to 0. This 15% is equal to 0.15 times A, or simplified as just 0.15A, and then 20% A is simplified just as 0.2A. So now we are ready to construct our piecewise function. In this case, we're going to name this function as k, with a as its variable, where a represents the annual income. Okay, a represents annual income. And it is constructed as, here there will be 3 lines. For the first line, we have 0 whenever the income is between 0 and 250,000. The second line will be 0.15a whenever the income is more than 250,000 but less than or equal to 400,000. And the third line will be 0.2a whenever the income is more than 400,000 but is less than 800,000. Okay, so as you have noticed, our third example is the simplest of all the examples that we've dealt with in this lesson. So let me encircle this.